All right, when we think about speed and velocity, we'll deal with speed first. Now, speed we're very familiar with. It's how far you've gone over how much time it took you to get there. That's why you say miles per hour or kilometers per hour, meters per second. Like this puppy dog on a skateboard. He's going, you know he's moving. He's like, yeah, I'm moving a distance and I'm doing it in time. So he has a speed. Or if you're out and you're surfing, you're going to be moving a distance and you're doing it within time, which means that he has a speed. Or if you're in a fighter jet, you have an incredible speed because you're going a lot of distance in very little time. Now, when we're discussing speed, speed does have a math component where speed is equal to distance divided by time. Now, don't be all whaley, math. Sure. So here's a triangle. Makes it even easier. If you don't know speed, you cover it up, which means you divide distance by time. If you don't know time, you cover it up, which means you divide distance by speed to get time. If you don't know distance, you cover it up, and then you multiply speed times time, and it gives you the distance. So don't be all whaley, math, when you can just use the triangle and cover stuff up. It's easy. Now, we use two different types of speed to talk about speed to other people. We use instantaneous speed and average speed. Instantaneous speed is happening right now. Right that moment. Right now. It's instantly. It's woo, woo, woo. It just happened. I'm in a forest. It is full of... The instantaneous speed at this exact moment is low. Probably around a meter per second. Of trees. I'm in a forest. Another frozen moment in time. Instantaneous speed at this exact moment. Still probably about 1 meter per second. Nothing frightens me. In this situation, the instantaneous speed is much higher. Probably around 3 meters per second. Freezing time again. It's all relative based on how fast the object is going at that exact moment. Now, average speed, you have to have more than one instantaneous speed involved in an average speed because it's taken over a greater amount of time. It's not, woo, it's just longer. So as you're walking along at a steady pace, maybe about a meter a second, and then you're just kind of like, you're going, and then you see something that's coming, you're moving faster, 3 meters per second, 4 meters per second, but it's okay. And when you describe what just happened, you're describing the initial speed and the final speed averaged together over the entire time and the entire distance that was traveled. But what about velocity? For example, if I have a guy who's riding on a bicycle and he's traveling at a speed of 4 meters per second. That's the speed. You could either say it was average or instantaneous, depending on whether you were doing it instantaneously or over the course of a journey. When it becomes a velocity is as soon as you add that component. You add a vector component or a direction. And then it becomes a velocity. As soon as you have a vector, a direction, it becomes a velocity. So a velocity is nothing more than a speed that has been given a direction. They're pretty equivalent. They're the same thing, except for a velocity has a direction. Because of this, I can go back to my triangle that helps me figure out the math stuff of speed and velocity and just kick speed out, put velocity in there, and it's the same triangle, the exact same thing. So for the purposes of understanding speed and velocity, they are pretty much the same thing, except for velocity has a vector or a direction.